It is very important question. Please try to understand very carefully. A ball of mass small m moving with velocity v naught collides with a spring and stick together. Find maximum compression of the spring. You can see this figure. This is a block of mass capital M and massless spring connected in this spring, a massless spring connected in the block look like this. A small m mass moves in straight line and then after collide in a spring. So a spring compress. A spring compress maximum, then all the blocks, that is both blocks moves together. At that time compression will be maximum, correct? Now, a spring compressed maximum, then both blocks moves together. This is very simple. A small m collide with a spring, then a spring compress. The maximum compression of a spring contain maximum energy. Then this energy, this spring energy, that is potential energy, transferred to the bigger block. Then bigger block moves. That is a spring energy get transfer in kinetic energy. So both moves together. Total energy initial equal to total energy final. Conservation of energy. Total energy initial 1 by 2 m v naught square. Only kinetic energy. A spring potential energy initially 0 because a spring in on a stretched state and this block at rest. So energy 0. Again, this energy 1 by 2 small m and capital M. Both moves together. This is the v square. Consider velocity of both block v after collision plus 1 by 2 k spring constant or maximum compression. We have to calculate x max. This 1 by 2 and 1 by 2 and 1 by 2 cancel. So m v naught square minus small m plus capital M into v square equal to k and x max. X max square equal to m v naught square minus small m plus capital M into v square divided by k. Square remove here and this is result. Now v naught given in question, small m capital M given, k given, v naught given. So we have to determine v and put here we get result. Correct? From conservation of momentum, P initial, P final, correct? Kinetic energy of the spring is 0. A spring having only potential energy because mass of the spring is negligible. So momentum of a spring also negligible, correct? Initially only m moves, so m v naught, this is the momentum, and capital M at rest, so 0. Finally, both moves, small m plus capital M with velocity v. This is the v. V equal to m v naught divided by capital M plus small m. Now this value is put here. We get x max m v naught square minus small m capital M and v m v naught square divided by small m and capital M square divided by k. We can write this and this cancel. Okay. X max equal to this is v naught square and this is the v naught square. So v naught comes outside the root, that's v naught. And here m, small m minus small m square divided by small m plus capital M divided by k. After solving this, comes here, m square cancel. So x max equal to v naught, correct, divide by small m, capital M, k, small m, capital M. After solving, we get this is answer. And very important and very conceptual problem. This questions levels like advanced. Okay? Any doubt? Any problem? Please subscribe my YouTube channel. Thank you.